Something is building in the Pacific Ocean right now, and it's going to change the weather across the entire United States, whether you're ready for it or not. What if I told you that the strongest El Nino in recorded history might be forming right now? Not in 5 years, not next decade, right now. What if the storm pattern hammering the plains this spring, the drought choking 55% of this country, and the eerily warm Atlantic Ocean that refuses to cool down are not separate stories, but the opening chapters of the same one? Because here's what the forecast models are showing that almost nobody is talking about yet. Two of the most powerful climate forces on Earth are on a collision course this year. El Niño, a Pacific giant that normally rewrites global weather on its own, is arriving into an Atlantic that is running hotter than it should be, on a planet that is already warmer than it has ever been in modern history. No one alive has seen these two forces meet at this intensity. Not once. We're going to answer the questions that the headlines aren't asking. Why is this El Niño different from everyone that came before it? What does it actually do to your weather, season by season, state by state? And what happens when the force that's supposed to protect America's coastlines from hurricanes is fighting a losing battle against a warming ocean? Stay with us. The answers will surprise you. Let's be precise about what this means. In the early months of 2026, the trade winds over the western Pacific Ocean, the invisible global conveyor belts that reliably push warm surface water toward the coast of Indonesia, did not just weaken, they collapsed. When those winds fail, the immense reservoir of warm water that has been pinned against the western edge of the Pacific suddenly has nothing holding it back. It obeys gravity. It sloshes eastward across the largest ocean basin on Earth, moving towards South America in a deep subterranean pulse known as an oceanic Kelvin wave. Think of it like a bathtub filled too high on one end. When you remove the physical barrier, the water instantly rushes back to find its level. But this is not a bathtub. This is an ocean covering 1/3 of the globe, and the wave moving beneath it right now is holding enough excess thermal energy to physically expand the height of the ocean's surface by several inches. Let that sink in for a moment, not metaphorically, not as a headline exaggeration, but as a physical restructuring of sea level driven entirely by trapped oceanic heat. Forecasters measure this phenomenon using the Oceanic Nino Index, or the ONOI. It is a metric that tracks the departure from average sea surface temperatures in a specific heavily monitored rectangle of water dead center in the equatorial Pacific, known as the Niño 3.4 region. A standard El Niño is officially declared when temperatures in this zone reach 0.5 degrees Celsius above normal. A super El Niño, the exact atmospheric configuration that unleashed fatal, terrain-altering mudslides in California in 1983 and caused an estimated $35 billion in global infrastructure collapse in 1998, requires a sustained deviation of 2.0 degrees Celsius. By the spring of 2026, the subsurface precursor to this event has not just triggered the 0.5 degree threshold. The deep water temperature anomalies, sliding eastward 150 meters beneath the surface, are tracking at a staggering 2.8 degrees above the baseline. The heat is trapped below the thermocline, the critical boundary layer separating warm, sunlit surface water from the freezing abyss below. The math broke. To understand the gravity of this data, we have to look at how we acquire it. In 1982, the global scientific community was virtually blind to the Pacific's temperature shifts. The Super El Niño of 1982-83 was already ravaging the Western Hemisphere before climatologists even realized what was happening. Commercial ships were reporting wild, anomalous temperatures off the coast of Peru, but the data was initially discarded by researchers as widespread equipment error. The most destructive climate disruption of the 20th century was initially dismissed as a broken thermometer. We are no longer blind. Today, the Pacific is monitored by the Tropical Atmosphere Ocean Array, a sophisticated network of 70 heavily instrumented buoys anchored directly to the ocean floor. These sensors record water temperature from the surface down to 500 meters, transmitting the data via satellite in real time. The 2026 data is not a forecast. It is not a projection. It is a physical reality. The buoys are transmitting anomalous readings so severe that technicians initially ran diagnostics to check for hardware failures. There were no hardware failures. Now, let us maintain our intellectual rigor here. Science has not connected every single atmospheric disaster of the modern era to El Niño. The collapse of the Pacific trade winds does not spontaneously create severe thunderstorms in the American Midwest, and it does not dictate the exact block-by-block path of a landfalling hurricane. We must explicitly detach from the idea that El Niño is a localized storm system. It is not. Here is why this matters. El Niño is an atmospheric architect. It dictates the environment in which all other weather exists. By moving millions of square miles of superheated water from Indonesia to the Galapagos Islands, it transfers a colossal, unprecedented amount of moisture and latent heat into the air directly above it. This creates a massive vertical column of rapidly rising air that fundamentally alters the circulation of the entire planet. It acts as a geological boulder dropped into the middle of a fast-moving atmospheric stream, forcing the global jet streams to permanently detour around it. The catastrophic events of 1997 taught forecasters that when the Pacific Ocean runs a severe fever, the atmospheric teleconnections are absolute, rewriting precipitation maps from the Horn of Africa to the Central Valleys of California with a terrifying mechanical predictability. The baseline has shifted. The Pacific is primed. The map is being rewritten again. To understand the scale of what is arriving in 2026, we must first abandon a fundamental public misconception. El Niño is not a storm. It is not a hurricane. It is not a prolonged weather front. It is a thermal engine. Let's be precise about what this means. The atmosphere and the ocean are not separate independent entities. They are a single, coupled mechanical system locked in a continuous physical dialogue. What happens in the water dictates the behavior of the sky. To understand the collapse, you must first understand the equilibrium. In a normal neutral year, the Pacific Ocean operates on a massive, highly predictable atmospheric loop known as the Walker circulation. The trade winds blow relentlessly from east to west along the equator. They act as a planetary broom, sweeping sun-baked surface water from the coasts of the Americas all the way toward the coast of Southeast Asia. This constant friction literally piles the ocean up. The sea level near Indonesia is physically 18 inches higher than it is near Ecuador, simply because the wind is holding it there. This is the baseline. This is the equilibrium. This is the engine working exactly as designed. Because this warm water is shoved westward, cold water from the deep ocean abyss is sucked up along the coast of South America to replace it. This process, called upwelling, keeps the eastern Pacific frigid. But more importantly, it anchors the atmosphere above it. Cold water does not evaporate efficiently. It cools the air, making it dense and stable. In a normal year, the eastern Pacific is a marine desert, devoid of significant storm activity, while the towering thunderstorms are strictly confined to the superheated waters of the western Pacific. Think of it like this. The Pacific Basin is a vast, geological-scale seesaw of atmospheric pressure. But in 22.6, the mechanics are breaking down. When the trade winds falter, the seesaw violently tips. The warm water that was pinned against Asia by the wind now flows backward, sliding east along the equator. It does not move quickly. It is a slow, silent, heavy migration of oceanic heat. As this thermal blob spreads across the central and eastern Pacific, it completely smothers the cold upwelling. The ocean's surface temperature spikes. The thermocline, the barrier between warm and cold water, is physically flattened, and then the atmosphere responds. Water stores heat perfectly. Air does not. When millions of square miles of the Pacific Ocean surface warm by a few degrees, the ocean rapidly sheds that excess thermal energy into the atmosphere through evaporation. This is driven by latent heat release. As water turns from liquid to vapor, it absorbs heat. When it condenses into clouds high in the atmosphere, it detonates that heat back into the air. We are not talking about a rain shower. We are talking about thousands of square miles of boiling atmospheric convection reaching the tropopause. 10 miles high. Stay with me for a moment. This single vertical column of rising air over the central Pacific is so vast, so unfathomably powerful, that it obstructs the entire global circulation of the planet. Here is the physical reality. As this massive updraft hits the ceiling of the troposphere, the air has nowhere to go but outward, spreading toward the Earth's poles. Because the planet is spinning, this outward flow of air crashes into the Earth's existing high-altitude wind currents. It generates massive atmospheric ripples known as Rossby waves. It acts quite literally as a geological boulder dropped into the middle of a fast-moving stream, forcing the water to aggressively detour around it. El Niño injects a staggering amount of momentum into the subtropical jet stream, a fast-moving river of air flowing high above the equator. It straightens it out. It forces it lower in latitude. It turns a meandering high-altitude wind into an aggressive, unyielding atmospheric fire hose aimed directly at the Americas. This is the true mechanical threat of the anomaly. The thermal engine of the Pacific does not need to send a single drop of rain to North America to alter its destiny. It simply changes the invisible tracks that every other storm on the planet must follow. It reshapes the atmospheric architecture of the Northern Hemisphere from 4,000 miles away. Let that land. The torrential rains that will drown California valleys and the blocking high-pressure systems that will bake the American plains are being physically authored right now by the water temperature off the coast of Peru. The years 1982 and 1997 share a specific vital characteristic with the year 2026. They all hosted the birth of a monstrous El Niño. But here is the divergence. Here is the sober reality. The atmosphere of 1997 no longer exists. By the spring of 2026, the planet has officially crossed a threshold that climatologists have modeled, debated, and warned about for 3 decades. The global average temperature is now firmly 1.5 degrees Celsius hotter than the pre-industrial baseline, not as a localized spike, not as a temporary seasonal anomaly, as a permanent, structural elevation of the Earth's thermal floor. To understand the consequence of this, we must translate temperature into physics. Enter the Clausius-Clapeyron relation. This foundational principle of thermodynamics dictates a cold, hard mathematical rule. For every 1 degree Celsius the atmosphere warms, its physical capacity to hold water vapor increases by roughly 7%. Let that sink in for a second. The sky is an invisible sponge. We have permanently increased the size, depth, and holding capacity of that sponge. At 1.5 degrees Celsius of warming, the global atmosphere is carrying over 10% more precipitable water than it did a century ago. Let us be intellectually honest here. The 1.5 degree baseline did not create the 22,006 El Niño. The Pacific oceanic cycles have oscillated for millennia, entirely independent of human activity. The warming baseline is not generating the subterranean Kelvin waves sliding beneath the equatorial Pacific right now. We must completely separate the trigger from the environment. Science does not suggest that climate change birthed this anomaly. Here is why this matters. Climate change did not birth the anomaly, but it weaponized the arena in which the anomaly operates. Think of it like this. Imagine a soundboard in a recording studio. An El Niño event pushes the volume fader of global weather up to a 10. In 1997, the master volume of the entire Earth system was set to a 5. The resulting weather was catastrophic. In 2026, the master volume of the Earth is set to an 8. Pushing the El Niño fader to a 10 now produces a level of atmospheric feedback that physically shatters the speakers. The floor has been raised. The ceiling is gone. This is why comparing 2026 to historical analogs is a fundamentally flawed exercise. When the 1982 El Niño transferred oceanic heat into the sky, it injected energy into a relatively stable, historically familiar atmospheric envelope. Today, the envelope is overloaded. Over the last 50 years, the world's oceans have absorbed more than 90% of the excess heat trapped by greenhouse gases. We measure this oceanic heat content in zettajoules. A single zettajoule is roughly equivalent to the energy of 25 billion atomic bombs. Over the last decade, the oceans have been absorbing 10 to 15 zettajoules of excess thermal energy every single year. The water is already at a rolling boil before the Pacific thermal engine even turns on. This baseline guarantees that every secondary effect generated by El Niño will be heavily subsidized by a deep reservoir of latent heat. When the shifting jet stream eventually points its moisture plumes at the west coast, the rain events will not just precipitate, they will gorge themselves on a hypersaturated atmosphere and collapse under their own immense weight. Conversely, when the pressure systems create localized droughts, they will not just dry the topsoil, they will structurally desiccate the earth, baking the ground into a frictionless concrete surface that accelerates dangerous runoff when the rains finally return. Stay with me for a moment. The severity of 2026 is not simply about how powerful the El Niño becomes. It is about the unprecedented, highly volatile atmosphere it is colliding with. We are injecting a historic weather disruption into a climate state that has never previously existed in human history. The physics do not care about historical averages. The physics only care about the energy available in the system right now. And right now, the system is loaded. The physical consequences of a shifting Pacific Ocean do not wait for winter. By the spring of 2026, the early atmospheric friction generated by this displaced thermal energy is already rewriting the mathematics of the American plains. Let's be precise about what this means. El Niño does not spontaneously manufacture tornadoes. We must explicitly detach from the idea that a warm ocean anomaly thousands of miles away directly spins up a funnel cloud in an Oklahoma wheat field. The Pacific thermal engine does not create the localized storms. It engineers the environment that makes them unkillable. To understand the violent prelude of the 2026 season, you have to understand the mechanical engine of the American Midwest. Every spring, the Great Plains become a topological battleground for three distinct, warring air masses. Frigid air plunging south from the Canadian prairies, bone-dry air sweeping east off the elevated Rocky Mountains, and hypersaturated, boiling air flowing north from the Gulf of Mexico. Where the dry, dense mountain air slams into the humid, buoyant Gulf air, a physical boundary is drawn across the Earth. Meteorologists call this the dry line. Think of it like this. The dry line is a tripwire. On the eastern side of that wire, the atmosphere is gorging itself on heat and humidity, building up a deep reservoir of raw, explosive potential. Forecasters measure this fuel using a thermodynamic metric called convective available potential energy, or CAPE. In a standard spring, CAPE values in Texas and Oklahoma might reach 1,500 joules per kilogram. That is a formidable amount of energy, sufficient to produce severe hail and standard supercells. But 22.6 is operating on a 1.5-degree elevated baseline, and the Gulf of Mexico is running a historic, unprecedented fever. The CAPE values are not sitting at 1,500. They are routinely pushing past 4,000 joules per kilogram. The atmosphere over the plains is so severely unstable that it is physically struggling to contain itself. It is held in check only by a capping inversion, a thin layer of warm air thousands of feet up that acts as a lid on a boiling pot. Then the Pacific engine turns on. As the oceanic Kelvin wave we discussed in Part 1 spreads across the equator, it violently accelerates the subtropical jet stream. It takes a meandering, high-altitude wind and straightens it into a ruthless atmospheric fire hose. By April of 2026, this jet stream is ripping across northern Mexico and directly over the Texas Panhandle at over 150 miles per hour, slicing right across the top of that boiling, volatile air mass. Here is why this matters. When that fast-moving jet stream crosses the dry line, it acts as a planetary vacuum. It aggressively evacuates mass from the upper atmosphere, forcing the heavily saturated air at the surface to violently rush upward to replace it. The lid on the boiling pot is physically ripped away. The thousands of joules of pent-up energy detonate upward in massive convective towers reaching 60,000 feet into the stratosphere. But the jet stream does not just lift the air, it twists it. This introduces the most consequential, destructive parameter in severe weather: vertical wind shear. Wind shear is a rapid change in wind speed and direction with height. Without wind shear, a standard thunderstorm rains into its own updraft. The cold, heavy precipitation falls, chokes off the warm surface air feeding the storm, and the system physically suffocates itself. It dies. But in the spring of 2026, the El Niño-juiced jet stream is blowing so fiercely at the top of the troposphere that it physically tilts the rising thunderstorms at a 45-degree angle. Let that land. The rain and hail no longer fall into the updraft. The structural intake of the storm is permanently separated from the exhaust. The system no longer suffocates. It breathes. This structural separation allows the storm to rotate, dropping the atmospheric pressure inside the updraft, exactly like water rushing toward a drain. The storm transitions from a disorganized cluster of rain into a highly structured, self-sustaining thermodynamic machine. And because of the sheer velocity of the altered jet stream above them, the storms of 2026 are not moving at a standard 20 miles per hour. They are racing across the ground at highway speeds, carving massive, anomalous long-track scars across the topography of the Midwest. The Pacific Ocean is actively feeding an atmospheric pressure cooker over the United States, and we have not even reached the summer. If the Pacific Ocean is the undisputed architect of global weather, The Atlantic Ocean is traditionally its silent partner. When the Pacific runs a fever during a super El Niño, it historically dictates the terms. The Atlantic complies, it absorbs the shifting winds, it quiets its hurricane seasons, and it behaves exactly as the models predict. But in 2026, the Atlantic is refusing to submit. We are witnessing the emergence of the Great Atlantic Paradox. The Pacific is currently spinning up the most mathematically violent thermal engine of our lifetimes, but it is encountering an Atlantic basin that is running a baseline fever so severe it has physically broken the forecasting charts. Let's be precise about what this means. We do not use the phrase "broken the charts" as a rhetorical flourish. In climatology, deviations from the average are measured in standard deviations. A localized ocean temperature running one standard deviation above normal is noteworthy. 2 is an extreme anomaly. By the time the 2026 El Niño fully engages, surface temperatures in the North Atlantic are routinely clocking in at 3 to 4 standard deviations above the 20th century average. In the waters west of Ireland and off the Iberian Peninsula, marine heat waves have recently reached Category 5. That is the highest categorization that exists. It is classified officially by the National Oceanic and Atmospheric Administration as beyond extreme. If you were tracking human height, a 3 standard deviation anomaly is an 8-foot-tall person walking into the room. It is statistically jarring. It forces you to recalibrate your understanding of what is physically possible. To grasp the sheer volume of heat trapped in the Atlantic, we must look at the math beneath the surface. Oceanographers measure deep-water heat accumulation not in degrees, but in a unit of energy called a zettajoule. A single zettajoule is roughly equivalent to the energy released by 25 billion atomic bombs. In the years leading up to 2026, the global oceans have been absorbing up to 15 zettajoules of excess thermal energy annually, and a disproportionate, staggering volume of that heat has parked itself directly in the North Atlantic. Here is why this matters. Forecasting the impact of El Niño relies entirely on historical analogs. Computer models are fed decades of data to understand how the atmosphere will react when the Pacific gets warm. But every single one of those historical blueprints assumes an Atlantic Ocean that is relatively stable. In 1982, the Atlantic was normal. In 1997, the Atlantic was normal. The models mathematically rely on the Atlantic acting as a thermodynamic heat sink, a cold, stable void that can absorb the atmospheric shockwaves generated by the Pacific in 2026. There is no void. The heat sink is already overflowing. We are introducing the greatest Pacific climate disruption in modern history into an Atlantic basin that is already boiling over with unprecedented latent heat. The traditional forecasting models are being fed an impossible equation. They are being asked to predict the outcome of an arm wrestle between 2 oceans, but they only have the historical data for one. Stay with me for a moment. This is not a localized problem for coastal communities. The thermal state of the Atlantic dictates the atmospheric pressure over the entire eastern half of the North American continent. When the Atlantic runs a catastrophic fever, it permanently alters the position of the Azores High, a massive, invisible mountain of atmospheric pressure that steers weather patterns from Europe to the Gulf of Mexico. The Pacific is trying to push its massive, moisture-laden jet stream across the United States. But the Atlantic, fortified by billions of atomic bombs worth of trapped heat, is building an unyielding atmospheric wall to block it. We are entering a meteorological stalemate of planetary proportions, and the battleground for this thermodynamic war is the airspace directly above the United States. 40 knots of vertical wind shear. In the high-stakes mathematics of meteorology, 40 knots is a death sentence for a tropical cyclone. It is the atmospheric equivalent of a planetary buzzsaw, and historically, it is the absolute, fail-safe defense mechanism that El Niño provides to the eastern seaboard of the United States. Let's be precise about what this means. A hurricane is often misunderstood as an indestructible, swirling tank of wind and rain. In reality, a hurricane is structurally fragile. It functions exactly like a vertical chimney. It requires a perfectly stacked, undisturbed column of rising air to pull heat from the ocean's surface and exhaust it 10 miles up into the stratosphere. If the top of that chimney remains perfectly aligned with the bottom, the engine efficiently combusts and the storm rapidly intensifies. But when El Niño violently accelerates the subtropical jet stream, as we discussed in Part 4, it floods the Caribbean and the Atlantic's main development region with high-altitude cross-basin winds. This is vertical wind shear. When those winds hit a developing hurricane at 40 knots, they literally decapitate the storm. The exhaust pipe is violently pushed out of alignment with the intake at the surface. The chimney collapses. The storm chokes on its own downdrafts and dies. For the entirety of modern observational history, a super El Niño guaranteed a suppressed, profoundly quiet Atlantic hurricane season. The shear was simply too hostile. But 2026 is introducing a lethal variable. The heat trapped in the North Atlantic is not just warming the surface, it is physically altering the density and buoyancy of the air directly above it. The Atlantic is shedding so much excess thermal energy through evaporation, a process called latent heat flux, that it is generating towering, violently explosive updrafts of air over the ocean basin. We are no longer talking about localized thunderstorms. We are tracking a structural transformation of the atmospheric column. Think of it like this. If you stack a column of dry leaves and blow a strong fan across the top, the stack instantly scatters. That is wind shear destroying a normal hurricane. But if you replace those dry leaves with a solid pillar of reinforced concrete, the fan does nothing. The sheer vertical momentum of the Atlantic's convection in 2006 is acting as that concrete. The updrafts inside these developing systems are so superheated, so buoyant and moving upward with such terrifying velocity that the high-altitude wind shear physically cannot blow them over. Here is why this matters. Forecasters are watching the traditional shield of El Niño fail in real time. In 2000-2003, scientists observed a minor preview of this paradox when an above-average hurricane season materialized despite a strong El Niño driven by record sea surface temperatures. But the 2026 anomalies are mathematically dwarfing the 2023 data. The Atlantic is not just resisting the shear, it is systematically overpowering it. The wind evaporation SST feedback loop is actively neutralizing the Pacific's influence. As the ocean heat forces immense amounts of water vapor into the sky, the latent heat release inside the storm clouds lowers the surface pressure so aggressively that it tightens the storm's core. A tighter core is exponentially harder for wind shear to disrupt. The Atlantic is essentially wrapping its storms in thermodynamic armor. Stay with me for a moment. This means that every major forecasting model built in the 20th century is currently blind to the threat. They are mathematically programmed to downgrade Atlantic hurricane probabilities the moment El Niño wind shear registers on the sensors. But the physics of 22.6 dictate that the shear is no longer a guaranteed kill switch. The defense grid has failed. The Pacific is pushing its atmospheric buzzsaw eastward, but the Atlantic is building hurricanes forged in an ocean that is running 3 standard deviations hotter than historical precedent. And as the calendar edges into the peak months of summer, these two immovable forces are going to violently collide over the warmest water on the planet. By July of 2006, the Northern Hemisphere enters the peak of summer, and the atmosphere over the Atlantic Ocean is effectively being ripped in half by 2 competing laws of physics. Let's be precise about what this means. The Pacific and the Atlantic are no longer just influencing each other, they are engaged in a brutal vertical tug-of-war over the exact same column of air. To understand the stalemate, we have to look at the exhaust pipe of the Pacific thermal engine. In Part 2, we discussed the massive updrafts generated by El Niño over the Central Pacific. But physics dictates that what goes up must eventually come down. When millions of tons of superheated air reach the stratosphere over the Pacific, they spread eastward, travel thousands of miles, and physically crash back down toward the surface over the Atlantic Basin and northern South America. Meteorologists call this large-scale descending air subsidence. Subsidence is the traditional assassin of Atlantic storms. As this air falls from the upper atmosphere, it mathematically compresses. As it compresses, it warms and aggressively dries out. It creates an invisible, crushing atmospheric lid over the ocean. It sinks, it compresses, it suffocates. In a standard El Niño year, this descending weight easily crushes developing tropical thunderstorms, flattening them against the ocean before they can organize into hurricanes. But 2026 is not a standard year. Beneath this falling anvil of dry Pacific air, the Atlantic Ocean is running a catastrophic, multi-standard deviation fever. The surface water is radiating latent heat flux at an unprecedented rate, desperately trying to exhaust its trapped thermal energy into the sky. It is generating localized, violently explosive updrafts that are attempting to punch vertically through the atmosphere. We have a localized collision of vertical momentum, At 30,000 feet, the El Niño engine is aggressively shoving the atmosphere downward. At sea level, the boiling Atlantic is aggressively pushing the atmosphere upward. Think of it like this. You are attempting to fully inflate a massive hot air balloon inside a room where the ceiling is mechanically lowering. The energy has nowhere to go. It is highly compressed. This compression fundamentally alters the most consequential feature of the summer Atlantic, the Bermuda Azores High. The Bermuda Azores High is a massive, semi-permanent mountain of high atmospheric pressure that typically sits quietly near the Azores, acting as the invisible steering wheel for summer weather. In a normal El Niño year, the Pacific's influence often weakens or shifts this high, allowing what few storms do form to drift harmlessly out to sea. But in 2026, the sheer thermal output of the superheated Atlantic Ocean is pumping this high-pressure system full of excess energy. It is not weakening, it is swelling. It physically expands westward, bridging across the ocean basin and parking its western edge directly over the eastern coastline of the United States. It forms an unyielding atmospheric wall. Here is why this matters. We are witnessing a meteorological stalemate of planetary proportions. The Pacific jet stream is trying to carve its way across the southern United States, but it cannot punch through the expanded Bermuda Azores wall. Simultaneously, the Atlantic's thermal energy is trying to spawn massive cyclonic systems, but they are being violently capped by the immense, sinking weight of the Pacific's subsidence. Neither ocean is winning cleanly. The atmosphere over the Caribbean and the Gulf of Mexico is trapped in a thermodynamic vice. The tension is building, the heat is compounding, and the standard forecasting models are outputting blank noise because they have never been asked to mathematically resolve a conflict of this magnitude. Stay with me for a moment. This stalemate does not mean the summer is safe. It means the physical energy is simply being deferred. And while the oceans wrestle for dominance in the sky, that expanded high-pressure dome over the United States is quietly inflicting a completely different kind of catastrophe on the ground below. By August of 2000, the atmosphere over the central United States is physically extracting hundreds of millions of gallons of water from the soil every single day, entirely independent of the lack of rainfall. Let's be precise about what this means. Drought is historically understood as a slow, creeping deficiency. It is a lack of precipitation measured over seasons, years, and decades. But the anomaly gripping 55% of the continental United States in the summer of 2026 is not a slow-moving historical event. It is a flash drought. To understand the brutal mechanics of this phenomenon, we must look back at the expanded Bermuda Azores High we discussed in Part 7. That massive, invisible mountain of atmospheric pressure has parked itself directly over the eastern and central United States. High pressure is, by definition, sinking air. As the air sinks, it compresses. As it compresses, it superheats, it stabilizes, and it aggressively dries out. It completely eradicates cloud cover. It allows maximum unfiltered solar radiation to relentlessly pound the surface of the Earth. But a lack of rain is only half of the equation. The true mechanical threat of 2026 is a metric climatologists call evaporative demand. Think of it like this. If you leave a wet sponge on a kitchen counter in a climate-controlled room, it will slowly dry out over a few days. That is standard evaporation. Now, point an industrial heat gun directly at that same sponge. The moisture is no longer just evaporating, it is being violently, physically extracted. Under the 2026 high-pressure dome, the sky is the heat gun. The atmosphere is so severely desiccated that it acts as a planetary vacuum, actively pulling latent moisture out of the grass, the crops, and the deep soil profile. The ground is literally bleeding water into the sky. Here is why this matters. When soil moisture drops this rapidly, the physical chemistry of the dirt fundamentally changes. Healthy topsoil is a thriving microscopic ecosystem. But as the flash drought rapidly evaporates the water, the organic matter and microorganisms in the soil die and decompose at an accelerated rate. As they break down under extreme heat, they release specific organic waxy compounds. These lipids coat the individual grains of dirt. The soil particles become encased in a biological wax. Soil scientists call this hydrophobic soil. It is a condition where the earth physically repels liquid. It does not matter if a rainstorm eventually arrives. The molecular structure of the topsoil has been altered to possess an extreme surface tension. Water beads up on contact. The ground no longer acts as a sponge. It acts as frictionless concrete. Let that sink in for a second. More than half of the United States, including the most critical agricultural belts on the planet, has not just dried out, it has been chemically sealed. We must maintain our intellectual honesty here. Flash droughts have happened before. The catastrophic drought of 2012 crippled the American Midwest and caused over $30 billion in agricultural losses. But the 2012 event did not have to contend with the looming, mathematically unprecedented moisture plume of a super El Niño waiting in the wings. The Pacific thermal engine is still running. The subtropical jet stream is still building strength, gorging itself on a 1.5-degree elevated baseline of planetary moisture. The stalemate over the Atlantic will not last forever. Eventually, the seasons will change, the high-pressure ridge will weaken, and the Pacific fire hose will finally break through and aim itself directly at the American continent. And when millions of tons of hypersaturated water finally crash down upon the United States, they will be hitting a landscape paved in hydrophobic wax. The flash drought is not just killing the crops, it is laying the frictionless runway for the floods. The thermodynamic stalemate of the summer cannot last. The Earth tilts. The northern hemisphere begins to cool, the expanded high-pressure domes finally begin to fracture, and the atmosphere attempts to transition into autumn. But in October of 2006, there is no smooth transition. There is only a tipping point. By the time the fall equinox arrives, the slow-moving subterranean pulse of oceanic heat we tracked in Part 1 has completed its trans-Pacific journey. The Kelvin wave physically slams into the continental shelf of South America and violently surfaces. The heat is no longer trapped 150 meters below. It is completely exposed to the open air. Millions of square miles of the equatorial Pacific, stretching from the international dateline to the coast of Peru, are now glowing in aggressive, uninterrupted crimson on satellite thermal imagery. The anomaly has reached its maximum geographical expansion. Let's be precise about what this means. The Pacific thermal engine is no longer just running. It has bolted itself to the floor. It is actively discharging a volume of water vapor and latent heat so massive that it permanently re-engineers the atmospheric architecture of the Northern Hemisphere for the remainder of the year. To understand this structural shift, we have to look toward the Gulf of Alaska. In a standard atmospheric configuration, the Northern Pacific Ocean hosts a semi-permanent weather feature known as the Aleutian Low. It is exactly what it sounds like, a broad, sprawling area of low atmospheric pressure that spins counterclockwise near the Aleutian Islands. It is the birthplace of normal winter storms. But when the superheated moisture from the 2026 El Niño travels northward and feeds into this system, the Aleutian Low does not just spin, it deepens. It aggressively and anomalously drops in pressure, driven by the sheer weight of the latent heat detonating inside of it. Think of it like this. If a standard low-pressure system is a gentle whirlpool in a stream, the El Niño-fueled Aleutian Low of 22.6 is an industrial drainpipe violently pulling the atmosphere down into it. Here is why this matters. The global jet stream is fundamentally a river of air that follows the path of least resistance around these massive pressure systems. When the Aleutian Low drastically deepens, it physically grabs the jet stream and violently pulls it northward toward Alaska, before slingshotting it thousands of miles southward on a steep, plunging trajectory toward the Hawaiian Islands and the Baja Peninsula. Climatologists call this atmospheric configuration the Positive Pacific North American Teleconnection Pattern, or the PNA. But this is not a meteorological abstraction. It is a permanent kink locked into the steering currents of the planet. Because the jet stream plunges so aggressively south over the eastern Pacific, it must eventually snap back northward. This forces a massive, unyielding mountain of high pressure to build over western Canada. And because it snaps northward over Canada, it must violently plunge southward again over the southeastern United States. Down, up, down. A planetary-scale standing wave. Stay with me for a moment. This specific, unyielding geometry is the hallmark of a super El Niño. Once this positive PNA pattern locks into place during the fall, the atmosphere loses its variability. The weather stops changing and simply begins repeating. The tracks are laid, the rails are bolted down. Every subsequent storm system that forms over the Pacific Ocean for the next 6 months will be forced into this exact atmospheric groove. We are no longer looking at a forecast. We are looking at a mechanical guarantee. The flash drought that baked the American soil into hydrophobic concrete throughout the summer is still sitting there. But now, the atmospheric fire hose has been securely mounted, aimed, and turned on. The transition season is over, and as late-season tropical systems continue to boil in the Caribbean, the continental United States is about to be caught in the crossfire of the most highly structured atmospheric river setup in modern history. While the Pacific Ocean permanently reconfigures the jet stream over the continental United States, the Atlantic hurricane season refuses to quietly die. In a standard year, by the time November arrives, the tropical Atlantic is effectively shut down. The waters cool, the air stabilizes, and the season ends. But in the fall of 2006, the storms simply retreat southward, dropping into a Caribbean basin that is currently holding the highest oceanic heat content ever recorded by human instruments. Let's be precise about what this means. Sea surface temperature only measures the thin upper skin of the ocean. It tells you how warm the water is at the exact point of contact with the air. But a hurricane does not just skim the surface. As a storm moves, its violent winds physically churn the ocean, dragging colder water up from the depths. If that deep water is cold, it instantly kills the storm's fuel supply. To measure the true explosive potential of an ocean basin, climatologists use a metric called ocean heat content, or OHC. It measures the total thermal energy trapped from the surface down to roughly 300 feet, calculated in kilojoules per square centimeter. A standard hurricane requires an OHC of about 50 kilojoules to sustain itself. In late 2006, the Caribbean Sea is not registering at 50. It is broadly reading at over 150 kilojoules per square centimeter, with isolated pockets pushing past 200. Think of it like this. If sea surface temperature is the match, ocean heat content is the depth of the gasoline pool. In the Caribbean, the pool is functionally bottomless. The water is superheated all the way down. When a storm churns the ocean here, it does not dredge up cold water. It dredges up more rocket fuel. But to ignite that fuel, a storm must first survive the Pacific's defenses. As we discussed in Part 6, El Niño operates by flooding the Caribbean with high-altitude, cross-basin wind shear. This shear acts as a planetary buzzsaw, specifically designed to rip developing storms apart. This brings us to the micro-loopholes. Wind shear is not a solid, impenetrable wall of air. It is a fluid, atmospheric river. And just like a physical river, it has eddies. It pulses. It experiences transient, localized lulls that might only last for 48 hours. Historically, a 48-hour lull was not enough time for a late-season storm to organize into a catastrophic threat before the shear returned to crush it. But 2026 is operating on an accelerated 1.5-degree baseline of thermodynamic energy. When a disorganized tropical wave drifts into the Caribbean and slips into one of these brief, low-shear windows, the unprecedented ocean heat content violently alters the mathematics of storm development. The system does not slowly organize over a week. It undergoes extreme rapid intensification. Because the water is superheated all the way down, the latent heat release into the storm is instantaneous and overwhelming. The pressure inside the core plummets. The eye clears. Within 36 hours, a disorganized cluster of thunderstorms physically mutates into a Category 4 hurricane. Here is why this matters. Once a hurricane achieves this level of structural maturity, it changes the rules of the environment around it. A major hurricane generates its own massive high-altitude outflow, a shield of air exhausting outward from the top of the storm. When the El Niño wind shear inevitably returns at the end of the 48-hour loophole, it no longer hits the fragile, developing core. It crashes into the storm's outflow shield and is deflected away. The storm has wrapped itself in thermodynamic armor. It is now completely immune to the Pacific's defenses. Stay with me for a moment. This exact, late-season, high OHC loophole is what birthed Hurricane Mitch in the El Niño year of 1998, a storm that claimed over 11,000 lives in Central America. But the Caribbean cauldron of 2026 possesses a thermal energy surplus that mathematically dwarfs 1998. We are tracking highly localized, hyper-intense cyclonic monsters forming at the exact moment the Pacific fire hose is locking into place over the United States. And as these late-season tropical systems drift northward out of the Caribbean, they are going to physically collide with the descending jet stream. 200 miles per hour, That is the velocity of the high-altitude wind current currently screaming across the Mexican border in the late fall of 2026. But the speed of this wind is not the part that has forecasters alarmed, it is the latitude. A massive, planetary-scale river of air has physically detached from its historical axis over the Pacific Northwest and plunged aggressively southward, actively hunting for moisture. Let's be precise about what this means. The subtropical jet stream is not a new phenomenon. It exists every winter. In a normal year, it is a fragmented, highly variable ribbon of air that meanders weakly across the middle of the Pacific Ocean. It often breaks apart before it ever reaches the North American coastline. But 2026 is not a normal year. We must return to the immense thermal engine of the Pacific we discussed in Part 2. The oceanic Kelvin wave has surfaced, and millions of square miles of superheated water at the equator are detonating latent heat into the stratosphere. This creates a colossal atmospheric blockade that the planet's high-altitude winds must physically navigate. As the northern hemisphere tilts into winter, the Earth's rotation, the Coriolis effect, interacts with this massive outward-flowing momentum from the equator. The subtropical jet stream does not just strengthen, it physically merges into a continuous, roaring loop. Think of it like this. Imagine a high-altitude, two-lane highway that is historically plagued with detours and road closures. During a super El Nino, that highway is instantly upgraded to a 10-lane unobstructed interstate, and the speed limit is completely removed. Here is why this matters. Because of the sheer size of the Pacific temperature anomaly in 2006, this atmospheric interstate is forced to dramatically lower in latitude. It physically drops hundreds of miles south of its normal position. It crosses the Baja Peninsula, rips across northern Mexico, and completely blankets the southern tier of the United States, from Texas to Florida. The rails are set. The weapon is pointed. The transition is complete. But a fast-moving jet stream alone does not cause a catastrophe. It requires fuel. And this is where the 1.5-degree elevated global baseline fundamentally alters the equation. As this jet stream drops south, it drags its intake hose directly across the superheated, hypersaturated waters of the eastern tropical Pacific. Because the atmosphere is permanently, structurally warmer, its capacity to hold water vapor has increased by over 10%. The jet stream gorges itself. It becomes completely, physically saturated. It transitions from a wind current into an atmospheric fire hose. Stay with me for a moment. This is the mechanical reality of the southern shift. The Pacific Ocean has built a high-speed conveyor belt specifically designed to transport millions of tons of aerosolized water from the equator directly to the Gulf Coast and the American Southwest. It bypasses the northern half of the United States entirely. The heavy, unyielding flow of moisture is now locked in over a landscape that, just months prior, was baked into hydrophobic concrete by the summer flash drought. We are no longer tracking tropical systems or localized severe weather. We are watching the permanent winter architecture of the Northern Hemisphere settle into its most hostile, violent configuration. And as the calendar turns to December, that fire hose is going to stop spraying a mist and begin unloading the structural equivalent of liquid mountains onto the coastline of California. 215,000 cubic meters of water per second. That is the average discharge of the Amazon River, the largest, most powerful body of flowing water on Earth. But the rivers currently taking shape over the Pacific Ocean in December of 2006 are not bound by banks or beds. They are suspended in the sky, and they are carrying more than double that volume. Let's be precise about what this means. An atmospheric river is not a metaphor. It is a literal, highly concentrated corridor of water vapor moving through the lower troposphere, roughly 2 miles above the ocean surface. In a standard winter, these invisible rivers are the lifeblood of the American West. They are normal, they are necessary. They are responsible for half of California's annual precipitation. But the megastructures forming off the coast in late 2006 are not normal. They have been mathematically re-engineered. To understand the sheer volume of water taking aim at the West Coast, we have to look at how climatologists measure these systems. They do not use rainfall inches, they use a metric called Integrated Water Vapor Transport, or IVT. It measures the physical mass of water vapor moving across a single meter of sky every single second. A standard, beneficial atmospheric river, a category 1 or 2 on the AR scale, registers an IVT of about 250 kilograms per meter per second. It brings mountain snow. It fills the reservoirs. It ends localized droughts. A Category 5 atmospheric river is a completely different thermodynamic beast. It requires an IVT pushing past 1,250 or a relentless duration exceeding 48 hours. In the winter of 2006, the Pacific fire hose is not generating Category 1S. It is systematically mass-producing Category 5S. Think of it like this. The atmospheric rivers of 2006, fueled by the 1.5-degree temperature baseline and driven by the unyielding El Niño jet stream we discussed in Part 11, are carrying the liquid equivalent of up to 10 trillion gallons of water a day. Let that sink in for a second. We are tracking a water volume that eclipses 2 Amazon rivers, suspended in a vapor corridor only a few hundred miles wide, traveling at highway speeds directly toward the California coastline. Here is why this matters. We discussed the Clausius-Clapeyron relation in Part 3. For every 1 degree Celsius of warming, the atmosphere holds 7% more water. The sky of 2026 is an enlarged, hypersaturated sponge. But El Niño does not just overfill the sponge. It fundamentally alters how the water is delivered. Because the jet stream has plunged so far south, and because it is drawing directly from the superheated equatorial Pacific, the moisture within these rivers is completely untethered from historical temperature profiles. In a normal winter storm, the snow level in the Sierra Nevada mountains might sit at 4,000 feet. The precipitation falls as snow, safely storing the water in a frozen reservoir that slowly, quietly melts over the spring. But these Category 5 atmospheric rivers are running hot. They are dragging tropical heat from Hawaii all the way to San Francisco. The freezing level does not sit at 4,000 feet. It skyrockets past 10,000 feet. This is the mechanical threat of the re-engineered atmospheric river. When these megastructures slam into the topography of the West Coast, they are forced aggressively upward by the coastal mountains. As the air rises, it cools, and the staggering IVT values instantly condense from vapor into liquid. But because the freezing level is so unnervingly high, the precipitation does not fall as snow. It falls almost entirely as torrential, high-velocity rain. Stay with me for a moment. This means the mountains are no longer acting as a storage bank. They are acting as a frictionless ramp. Every single drop of those 10 trillion gallons of water is going to hit the terrain and immediately rush downward. History provides exactly one analog for this atmospheric setup. In the winter of 1861 and 1862, a relentless sequence of warm atmospheric rivers hammered California for 43 consecutive days. The runoff from the Sierra Nevada mountains transformed the Central Valley into a literal inland sea, 300 miles long and 30 feet deep. The state was fundamentally submerged. The 1862 storm was historically viewed as a once-in-a-millennium anomaly. But the Pacific engine of 2026 has successfully reconstructed the precise atmospheric geometry required to repeat it, armed with a 1.5-degree thermal advantage that 1862 never had. And as we established in Part 8, this water is rushing down onto a landscape that has been baked into a hydrophobic concrete shell. The transition from severe structural drought to relentless flooding will not happen over months. It will happen in a matter of hours. By January of 2026, the transition is complete. The Pacific Ocean stops withholding water from California and begins weaponizing it. Let's be precise about what this means. Climatologists refer to this violent atmospheric pendulum swing as hydroclimate whiplash. It is the rapid, devastating transition from extreme structural drought directly into historic precipitation. But the mechanical danger of whiplash is not just the volume of the incoming water, it is the speed of the runoff. In Part 8, we discussed how the summer flash drought baked the California topsoil into hydrophobic concrete. The ground physically repels moisture. When the Category 5 atmospheric rivers we tracked in Part 12 finally make landfall, they are not softly soaking into the earth. The rain hits the coastal mountains, the Sierra Nevada, and the Central Valley, and it instantly translates into high-velocity surface runoff. Think of it like this. You cannot revive a bone-dry, dying houseplant by instantly upending a 5-gallon bucket of water over it. The dirt cannot absorb it. The water simply floods over the rim and ruins the floor. Now, scale that bucket up to 10 trillion gallons of water a day. Here is why this matters. The state of California is defended by a vast, intricate network of dams, levees, and concrete spillways. But this system was engineered and built in the middle of the 20th century. It was mathematically designed to manage a climate that no longer exists. In a normal, historical winter, precipitation falls primarily as snow in the high elevations. The mountains act as a natural, time-released reservoir. The dams below only have to manage the slow, predictable, highly manageable melt in the spring. But because the 2006 El Niño has aggressively pushed the atmospheric freezing level above 10,000 feet, the precipitation is falling as torrential rain. The natural mountain reservoir has been bypassed entirely. Every drop of water is rushing into the man-made lakes simultaneously. We do not have to guess what happens when this infrastructure is overwhelmed. We saw the preview in February of 2017. During that winter, a sequence of intense, warm atmospheric rivers dumped massive amounts of rain onto an existing snowpack above Lake Oroville, California's second-largest reservoir. The sheer volume of incoming water forced dam operators to open the main concrete spillway to prevent the dam from overtopping. The flow was so violent that it physically tore a 250-foot crater into the reinforced concrete chute. When operators desperately diverted the water to an unlined emergency spillway, the barren hillside immediately began to aggressively headcut and erode, threatening to undermine the concrete weir and send a 30-foot wall of water into the towns below. Nearly 188,000 people were forced to immediately evacuate. The repairs cost over $1 billion, and that was a localized failure during a storm sequence that climatologists later determined was not mathematically extraordinary. But 2026 is extraordinary. The atmospheric rivers of 2026 are operating on a 1.5-degree elevated baseline. The atmospheric fire hose is firmly locked into place by the Pacific thermal engine. The water managers of California are currently trapped in an impossible zero-sum game. If they hold the water to break the historic drought, the dams risk physical failure under the immense structural weight. If they open the spillways to save the dams, they artificially flood the downstream communities they were built to protect. Stay with me for a moment. This is the brutal mechanical reality of hydroclimate whiplash. The drought does not safely cancel out the flood. The drought engineers the precise physical conditions required to make the flood catastrophic. And as the water violently fills the valleys, it is simultaneously destabilizing the scarred, elevated terrain above it, setting the stage for a completely different kind of disaster. 0.54 inches of rain in 5 minutes. That is not a catastrophic volume of water on its own, but that exact mathematical rate of precipitation is what triggered the deadly Montecito debris flow in 2018, a disaster that moved boulders the size of train cars and flattened entire neighborhoods. The rain is merely the kinetic trigger. The true weapon is the terrain it falls on. Let's be precise about what this means. In Part 13, we established that the Category 5 atmospheric rivers of 2006 are dropping unprecedented volumes of water onto the California landscape. But this water is not hitting pristine natural mountainsides. It is colliding with a topography that has been systematically, structurally compromised by a decade of unprecedented megafires. To understand the topographical trap, we must look at the legacy of the 2020 and 2021 fire seasons. In those 2 years alone, over 6.7 million acres of California burned. The 2020 August complex fire alone consumed over 1 million acres, the first gigafire in modern state history. When a megafire burns at temperatures exceeding 1,500 degrees Fahrenheit, it does not just consume trees, it fundamentally alters the chemistry and architecture of the Earth. Here is the mechanical reality. Healthy soil is held together by vast, invisible networks of root systems. These roots act exactly like rebar in poured concrete, providing immense structural tension that keeps the mountainside anchored against the pull of gravity. A megafire entirely incinerates this biological rebar, but the fire does something even more insidious to the dirt itself. Extreme heat physically vaporizes the natural resins and waxy organic compounds inside the burning vegetation. As this vapor is pushed downward into the cooler dirt below, it condenses. It physically coats the soil particles in a thick, impermeable chemical wax. In Part 8, we discussed how extreme drought creates temporary hydrophobic soil. But fire-induced hydrophobic soil is a different beast entirely. It is a permanent chemical seal. The mountainside does not just resist water, it acts exactly like a Teflon pan. Think of it like this. In a healthy forest, A mountain acts as a sponge, slowing the water down and drawing it deep into the aquifers. On a severe burn scar, the mountain acts as a frictionless ramp. When the superheated, hypersaturated atmospheric rivers of 22,006 slam into these millions of acres of burn scars, the water cannot penetrate the waxy seal. It instantly sheets off the surface, gathering speed. As it rushes downhill, it encounters soil that has zero root structure holding it in place. The rushing water physically absorbs the mountain. It transitions from a flood into a debris flow. Stay with me for a moment. We must explicitly detach from the idea that a debris flow is just muddy water. It is a non-Newtonian fluid. It is composed of more than 50% solid mass, mud, ash, sand, gravel, and trees, suspended in a liquid matrix. Because of the incredible pore fluid pressure inside the mixture, a debris flow behaves structurally like wet concrete, yet it is capable of moving at highway speeds. Standard floodwaters flow around obstacles. A debris flow does not. Because of its immense density, it possesses a terrifying kinetic buoyancy. It can effortlessly lift and carry multi-ton boulders, uprooted oak trees, and entire homes as if they were made of styrofoam. In steep, fire-scarred canyons, these flows routinely reach velocities of 30 to 40 miles per hour. This is the catastrophic convergence of 2026. The Pacific Thermal Engine has aimed an atmospheric fire hose at the west coast, dropping localized rainfall rates that easily eclipse the half-inch in 5 minutes threshold. But instead of hitting one isolated burn scar, this moisture is raking across a state burdened by over 7 million acres of highly vulnerable, chemically sealed, frictionless terrain. The mountains are effectively liquefying, and while the west coast physically collapses under the weight of the Pacific's water, the southern United States is about to realize that the shifted jet stream has not forgotten them. 42 fatalities in a single February night. That was the human toll of the 1998 Florida tornado outbreak, the deadliest in the state's history, and a disaster birthed entirely by the atmospheric physics of a super El Nino. But the 2026 forecasting models for the American Gulf Coast are not predicting a single isolated night of violence. They are projecting a 3-month, uninterrupted barrage. Let's be precise about what this means. Winter in the American South is historically defined by a quiet, stable atmosphere. The severe weather season of spring is months away. The Gulf of Mexico naturally cools down, depriving developing thunderstorms of their essential thermal fuel. The air is dense, and the skies are relatively calm. But in the winter of 2026, the calendar is irrelevant. The Gulf Coast is experiencing a winter without winter. To understand the mechanical threat of this endless season, we must return to the southern shift we explored in Part 11. The colossal Pacific Thermal Engine has physically dragged the subtropical jet stream hundreds of miles south of its normal position. That 200-mile-per-hour river of air is no longer meandering weakly over the ocean. It is permanently parked directly over the Interstate 10 corridor, stretching continuously from Texas to the Florida Peninsula. Think of it like this. The jet stream is an industrial exhaust fan, aggressively ventilating the upper atmosphere. When it sits directly over the Gulf Coast, it creates a planetary-scale vacuum, violently pulling the surface air upward to fill the void. But this vacuum requires intake, and the intake for the Gulf Coast is the Gulf of Mexico itself. Here is why this matters. In a standard El Nino year, this southern storm track brings dreary, cloudy, and persistently wet conditions to the south. It is an annoyance. But the Gulf of Mexico in 2206 is operating on the 1.5-degree elevated baseline. It is not just warm, it is holding unprecedented ocean heat content. It is actively radiating latent heat and hypersaturated moisture into the lower atmosphere, completely refusing to undergo its normal winter cooling cycle. When the screaming 200-mile-per-hour Pacific jet stream crosses over this boiling, hypersaturated Gulf moisture, it replicates the exact highly explosive thermodynamic conditions usually reserved for Tornado Alley in the middle of May. Let us maintain our intellectual rigor here. El Nino does not spontaneously generate a tornado in a Florida neighborhood. The ocean temperature in the Pacific does not physically spin up the funnel cloud. We must explicitly detach from that misconception. What the Pacific anomaly does is engineer the violent vertical wind shear environment that makes severe rotation possible, while the abnormally warm Gulf provides the thermodynamic fuel. The vertical wind shear. The rapid change in wind speed and direction with height is absolute. The instability is off the charts. The atmospheric lid is completely ripped away. We are not talking about standard winter rainstorms. We are tracking a relentless, multi-month conveyor belt of highly organized, rotating supercells. Stay with me for a moment. The true terror of a super El Niño winter in the deep south is the timing. During the traditional spring severe weather season in the plains, storms typically peak in the late afternoon, driven by solar heating. The sun goes down, the atmosphere cools, and the storms eventually decay. But the atmospheric dynamics of the 2026 jet stream are so overpowering that they do not require the sun. The sheer kinetic force of the wind is enough to sustain the updrafts. The most violent cyclonic systems are triggering at 2 o'clock in the morning. We do not have to theorize the outcome. During the 1998 Super El Niño, a fast-moving jet stream combined with Gulf moisture to spawn the Night of the Tornadoes in central Florida. 7 catastrophic tornadoes, including 3 violent F3s, touched down while the state was asleep. They moved at highway speeds. They flattened thousands of structures. They killed 42 people and injured hundreds more in total darkness. But the 1998 outbreak was an anomaly in a season of rain. The 2026 atmospheric configuration is a permanently locked mechanism. The Gulf of Mexico has the thermal energy to sustain this violent convection from December straight through to March. Let that sink in for a second. Millions of residents from Houston to Orlando are trapped beneath a semi-permanent shear zone, enduring a daily, exhausting threat of nocturnal tornadoes and catastrophic flash flooding. The infrastructure is battered. The emergency management resources are depleted by week 3. The South is drowning in a violent, endless spring. But as we look northward, away from the screaming jet stream, we find a completely different kind of atmospheric terror. The northern United States is not experiencing a storm. It is experiencing an unnerving, unprecedented void. 0.5%. That is the total basin-wide ice coverage across the 5 Great Lakes in the middle of February. But the loss of the ice is not the part that has forecasters alarmed. It is the structural absence of the season itself. We are tracking a region of the continent that has been entirely severed from the Arctic. Let's be precise about what this means. Winter in the upper Midwest is historically defined by the polar jet stream, a meandering river of air that routinely sags southward, pulling frigid Canadian air down into the United States. It brings the deep freezes, it brings the blizzards, it lays down the critical insulating snowpack, but in the winter of 2026, the polar jet stream has been physically walled off. To understand this northern void, we must look back at the atmospheric geometry we built in Part 11, when the colossal Pacific thermal engine dragged the subtropical jet stream deep into the American South. It forced a corresponding reaction in the north. Physics demands balance. Because the southern jet stream plunged so violently, the atmosphere over Western Canada was forced to aggressively buckle upward. It built a blocking ridge. A blocking ridge is a massive, stationary dome of high atmospheric pressure. In late 2000-2006, this dome is parked firmly over British Columbia and the American Northwest. It acts as an unyielding, planetary-scale barricade. When the frigid, dense air of the polar vortex attempts to slide south toward Minnesota and Wisconsin, it hits this invisible wall and is immediately deflected north into the high Arctic, or shoved thousands of miles east out into the Atlantic Ocean. The cold simply cannot get in. Here is why this matters. We are not talking about a mild winter, we are tracking the total eradication of the season. In a standard year, cities from Minneapolis to Green Bay rely on a consistent snowpack to insulate the ground, reflect solar radiation, and provide a slow, measured melt for agriculture in the spring. In 2026, there is no snowpack. The landscape is locked in an unending, unnerving brown. Temperatures in February are routinely pushing past 60 degrees. Without the protective blanket of snow, the bare, exposed topsoil continues to lose deep moisture to the wind and the anomalous warmth. The catastrophic flash drought we tracked in Part 8 does not end with the transition to winter. It simply changes phases, deeply desiccating the frozen earth. And nowhere is the thermodynamic consequence of this void more visible than on the Great Lakes. Historically, the Great Lakes experience a basin-wide maximum ice coverage of roughly 53% by late February. In 2014, coverage surpassed 80%. In the strong El Niño winter of 2024, it dropped to a shocking 2.7%. In 2026, operating on a 1.5-degree elevated planetary baseline, the ice has functionally ceased to exist. Lakes Erie and Ontario are entirely open water. Lake Superior, the coldest and deepest of the five, is bearing less than 1% ice cover. Think of it like this. Ice is not just frozen water, it is a thermal shield. A bright white ice cap reflects the sun and tightly seals the heat of the lake inside, preventing the water from evaporating into the dry winter air. When you remove that shield, the lake bleeds. The dark, exposed water absorbs what little solar radiation is available, maintaining an anomalous heat memory from the summer. Because there is no ice cap, the lakes aggressively evaporate directly into the atmosphere all winter long. Shorelines that are usually protected by thick, immobile ice shelves are instead pulverized by relentless wind and wave action, accelerating catastrophic coastal erosion. The biological rhythms of the lakes are thrown into complete chaos. Fish species that rely on the ice for protection from predators during their winter spawning season find themselves entirely exposed. The equilibrium of the ecosystem collapses. Stay with me for a moment. While the Gulf Coast is drowning under a barrage of nocturnal tornadoes, and California is being structurally dismantled by Category 5 atmospheric rivers, the upper Midwest is experiencing a terrifying silence. The danger of the northern void is not a sudden violent storm. It is the permanent withdrawal of a climate pillar. The region has been physically disconnected from its historical weather patterns, and the silent structural damage of this snowless winter is about to violently collide with the spring planting season. 1/3 of the United States' total corn supply is grown in just 2 states, Iowa and Illinois. But by April of 2026, the physical condition of the soil in these states is fundamentally broken. Before a single tractor enters a field, the mathematical foundation of the American harvest has already collapsed. Let's be precise about what this means. Modern agriculture is not just about having fertile dirt. It is a highly choreographed, thermodynamic ballet. It requires precise soil temperatures, predictable moisture profiles, and an exact window of time to plant seeds. If any one of those atmospheric pillars falls out of alignment, the crop yield plummets. In the spring of 2026, every single pillar is missing. To understand the agricultural shockwave, we have to look at the dual extremes created by the Pacific thermal engine. The United States has been severed into 2 completely unworkable environments. First, let us examine the North. In Part 16, we detailed the Northern Void, a winter completely devoid of snowpack. For the millions of acres of winter wheat planted across the Midwest and Great Plains the previous autumn, that snowpack is not just precipitation, it is a vital biological shield. Winter wheat survives the freezing temperatures by going dormant, relying on a thick blanket of snow to physically insulate its fragile crown from sub-zero winds. Think of it like this. Snow is an atmospheric down jacket. Without it, the plant crown is exposed to extreme temperature fluctuations and relentless, desiccating wind. The anomaly of the 2026 winter meant that the wheat never received its insulation. The crops simply froze, dried out, and died in the barren earth. But the lack of snow creates a much larger structural crisis for the spring corn and soybean planting. Historically, the spring thaw is a slow, methodical process. Melting snow gently recharges the deep subsoil moisture, providing a crucial reservoir of water for the seeds to tap into during the hot summer months. In 2026, there is no melt. The catastrophic flash drought from the previous summer never actually ended. It simply went dormant in the cold. When farmers attempt to plant in April, they are driving steel discs into earth that is alarmingly dry. The topsoil is dust. The subsoil is barren. But directly to the south, the agricultural reality is violently inverted. In Part 15, we established the Gulf Coast's endless winter, a relentless barrage of severe weather and heavy rain driven by the southern shifted jet stream. By the time spring arrives, that moisture plume has slowly crept northward into the lower Midwest and the southern plains. Here is why this matters. A farmer cannot run a 40,000-pound planter through a flooded field. If the soil is completely waterlogged, the heavy machinery sinks, the dirt compresses into impenetrable clumps, and the seeds physically rot in the mud before they can germinate. We are watching the complete, mechanical inversion of historical precipitation patterns. The northern half of the American breadbasket is too structurally desiccated to sprout seeds, and the southern half is too violently saturated to even attempt planting them. Stay with me for a moment. The planting window for maximum corn yield is astonishingly narrow, typically a few weeks in late April and early May. Every single day that planting is delayed beyond this window, the mathematical ceiling for the fall harvest drops. The 1.5-degree elevated baseline ensures that the summer waiting on the other side of this spring will be brutally hot. If the corn is planted too late, its critical pollination phase, when the plant forms its kernels, will perfectly align with the absolute peak of the summer heatwave. Extreme heat physically sterilizes the corn pollen. The crop will simply abort. We must explicitly detach from the idea that a bad harvest is a localized problem. The Midwest dictates the global commodity markets. 75% of the region's arable land is locked into corn and soybeans. When the planting cycle is destroyed on this scale, it does not just mean higher prices at the grocery store. It guarantees a cascading structural failure of the global food supply chain. And the financial shockwaves of that failure are about to collide with an insurance industry that is already collapsing under the weight of the water. $275 billion. That is the combined staggering cost of the 55 separate billion-dollar weather disasters the United States endured in just 2003 and 2004. But the sheer volume of that financial hemorrhage is not the part that has economists panicked. It is the mathematical realization that the foundational risk models governing the global economy are structurally obsolete. We are no longer tracking physical weather. We are tracking a cascading financial collapse. Let's be precise about what this means. A catastrophe does not end when the atmospheric river shuts off or the tornado dissipates. It simply changes mediums. The destruction violently transitions from the physical world into the financial world. To understand the scale of the 2006 economic cascade, we must first look at the agricultural shockwave we established in Part 17. The complete inversion of the American planting season does not just empty the silos in Iowa and Illinois, it severs the anchor of the global supply chain. Corn and soybeans are not just food. They are industrial-based commodities. They feed the livestock. They produce the ethanol. They act as the chemical foundation for thousands of manufactured goods. When the Midwestern crop yield plummets, the commodity markets do not just adjust. They violently detach from reality. Think of it like this. The global food supply chain operates on a just-in-time delivery model, engineered for maximum efficiency and zero friction. It assumes a predictable, stable climate. When the 2026 El Niño structurally eradicates the harvest, it throws a massive, physical wrench into a frictionless machine. The price of basic staples skyrockets overnight. The disruption cascades down the Mississippi River, freezing exports, bankrupting heavily leveraged farming conglomerates, and triggering acute food insecurity in developing nations thousands of miles away. But the agricultural failure is only the first domino. The true, terrifying structural collapse is occurring in the coastal housing markets. By the time the Category 5 atmospheric rivers of 2026 systematically dismantle the California topography, the state's insurance market is already a ghost town. In 2000-2003, industry giants like State Farm and Allstate explicitly halted new homeowners' policies across California, citing skyrocketing construction costs and uncontrollable climate-driven catastrophe exposure. In Florida, grappling with its own unprecedented oceanic heat and relentless storm seasons, insurers have been fleeing for years, heavily relying on a teetering state-backed insurer of last resort. They did not pause business because of a single storm. They paused business because the 1.5-degree elevated atmospheric baseline physically broke their algorithms. Here is why this matters. The entire concept of insurance is based on historical pooling. You take decades of past weather data, run a statistical model, and charge premiums based on the calculated risk of a disaster occurring. But when you inject a super El Niño into a permanently altered, hyper-saturated atmosphere, history is no longer a valid map. The past ceases to be a predictor of the future. When the historical models fail, the primary insurers have to rely on a hidden layer of the global financial system called reinsurance. Reinsurance is, quite literally, insurance for the insurance companies. It is the ultimate global safety net, designed to absorb the shock of massive multi-billion-dollar localized disasters. But in the wildcard season of 2026, the disasters are not localized. The Pacific thermal engine has simultaneously triggered catastrophic hydro whiplash in California, a relentless tornado barrage in the Gulf Coast, and agricultural collapse in the Midwest. The reinsurance companies are experiencing a terrifying synchronized drawdown of capital. They are being hit from every geographic angle simultaneously. Their response is mechanical and unyielding. They drastically raise their rates, or they completely pull their coverage. When the reinsurers pull back, the primary insurers instantly lose their financial shield. They have no choice but to pass those catastrophic costs onto the consumer, jacking up premiums by 50, 80, or 100%. But in high-risk zones, like the fire-scarred hills of California or the hurricane-battered coasts of Florida, they simply abandon the market entirely. They refuse to write the policy at any price. Let that land. We are not talking about expensive insurance. We are talking about uninsurability. Stay with me for a moment. This is where the weather permanently alters the structure of American society. A home is the foundational asset of the American middle class. But a bank will not issue a 30-year mortgage on an asset that cannot be insured against catastrophic loss. Without a mortgage, the house cannot be sold. Without buyers, the property value instantly evaporates. The physical destruction of 22,260 is terrifying, but it is the financial aftermath that traps millions of people in a geographical prison. The water will eventually recede, but the economic architecture that allowed those communities to rebuild in the 20th century has been completely mathematically erased. 20% of the world's fish meal supply originates from a single, highly specialized corridor of cold water off the coast of Peru. But by the middle of 2026, that water is no longer cold. The foundation of the marine food web has completely suffocated. Let's be precise about what this means. The atmospheric shockwaves of this specific El Niño do not stop at the US border. They are systematically dismantling the ecological and economic pillars of the Southern Hemisphere, engineering a synchronized global drawdown of natural resources. To understand the scale of this global domino effect, we must look first beneath the surface of the Pacific. In a standard, neutral climate year, the coast of South America is defined by the Humboldt Current. As the trade winds blow west towards Asia, they physically push the surface water away from the South American coastline. To fill the void, freezing nutrient-dense water from the deep ocean abyss is violently sucked up to the surface. This process is called upwelling. It creates a thriving, hyperproductive marine desert that sustains the largest single-species fishery on Earth, the Peruvian anchoveta. But in 2026, the mechanics of upwelling are mathematically broken. When the subterranean Kelvin wave we tracked in Part 1 successfully crosses the Pacific, it violently flattens the thermocline, the barrier between warm and cold water. Millions of square miles of superheated water smother the South American coastline. The upwelling does not simply weaken, it physically hits a thermal ceiling and stops. Here is why this matters. Without the deep-sea nutrients, the phytoplankton die. Without the phytoplankton, the anchovies starve, fail to reproduce, or migrate to depths where nets cannot reach them. The collapse is instantaneous. We do not have to guess what this looks like. During the moderate El Niño of 2023, the Peruvian government was forced to completely cancel the first anchovy fishing season because 86% of the sampled biomass consisted of underweight juveniles. That single cancellation erased an estimated $1 billion from the Peruvian economy and sent global prices for agricultural feed skyrocketing. But 2006 is not a moderate event. Operating on a 1.5-degree elevated planetary baseline, the ocean heat content is so severe that it is not merely disrupting a season, it is inducing a multi-year population collapse. And because the anchovy is the foundational keystone species, the starvation rapidly cascades upward. Millions of seabirds, sea lions, and marine mammals that rely on this specific corridor of water simply starve to death on the beaches. While the Eastern Pacific physically boils, the Western Pacific is dying of thirst. To understand the second domino, we must return to the Walker circulation. In Part 2, we likened the Pacific Ocean to a massive bathtub, where the trade winds pile warm water up near Indonesia and Australia. The sea level there is physically higher. But when the winds collapse in 2026, the water rushes back towards the Americas. Think of it like this. The bathtub is draining from the west. The sea level around Indonesia physically drops, but the water does not leave alone. It takes the atmosphere with it. Because warm water drives evaporation, and evaporation drives rainfall, The mass migration of the Pacific's thermal engine physically drags the rain clouds 8,000 miles to the east. Australia and Indonesia are structurally starved of moisture. Let us maintain our intellectual rigor here. El Niño does not spontaneously ignite a bushfire in the Australian outback. The shifting Pacific Ocean currents do not strike the match. We must explicitly detach from the idea that the ocean causes the spark. What the Pacific anomaly does is engineer the bone-dry, highly desiccated environment that guarantees a single lightning strike will transition into a continent-spanning inferno. Under the sinking, highly compressed air left behind by the migrating Pacific engine, Australia bakes. The humidity plummets. The vegetation desiccates into explosive kindling, and because the global temperature baseline is 1.5 degrees hotter, the heat waves striking the continent during this structural drought are mathematically unendurable. Stay with me for a moment. This is the true definition of a global teleconnection. A single thermal engine in the equatorial Pacific is simultaneously detonating atmospheric rivers over California, tearing apart the agricultural cycles of the American Midwest, suffocating the largest fishery in South America, and turning the Australian continent into a frictionless tinderbox. The models are not predicting independent, isolated tragedies. They are tracking a highly organized, physically connected failure of the planetary operating system. And as the data comes in, the scientists attempting to forecast these failures are realizing that the supercomputers they rely on are beginning to physically blind them. 30 quadrillion calculations per second. That is the operational processing speed of the National Oceanic and Atmospheric Administration's premier supercomputing system in 2026. It is a multi-million-dollar monument to human mathematics, designed to ingest billions of data points from satellites, buoys, and aircraft, and seamlessly simulate the future of the Earth's atmosphere. But by the summer of 2026, the scientists operating this machine are watching it fail. Let's be precise about what this means. The supercomputers are not experiencing a hardware glitch. They are not suffering a power outage. They are executing their code perfectly. The failure is entirely conceptual. The models are outputting blank noise, wildly diverging scenarios, and mathematically impossible weather maps. To understand why the machines are breaking, we must understand how a predictive model actually thinks. A climate model does not have intuition. It has memory. It relies on massive, deeply archived datasets known as reanalyzes. When forecasters want to know what a Category 5 atmospheric river will do when it hits the Sierra Nevada mountains, or how vertical wind shear will interact with a hurricane, the supercomputer looks backward. It scours decades of 20th century data to find the closest historical analog. It calculates how the atmosphere resolved that tension in the past and applies those physics to the present. But 2026 is operating on a 1.5 degree elevated baseline. There is no historical analog for an equatorial Pacific Ocean carrying this volume of trapped thermal energy. There is no reanalysis data for a North Atlantic basin running a Category 5 marine heatwave, while simultaneously fighting a super El Niño. When the machine searches its archives for a precedent where 55% of the continental United States is covered in fire-induced hydrophobic soil during a winter hydro-whiplash event, the archive returns nothing. The supercomputer is mathematically blind. Think of it like this. You have the most advanced GPS navigation system ever built, but if you try to drive off the edge of the mapped world into a terrain that has never been charted, the GPS cannot tell you where the cliffs are. It will simply tell you to turn around. Here is why this matters. We saw the cracks forming in the system years prior, during the unprecedented ocean heat anomalies of 2023 and 2024. The world's leading forecasting centers, from NOAA to the European Centre for Medium-Range Weather Forecasts, ECMWF, publicly acknowledged that their models struggled to predict the sheer magnitude of the warmth. The statistical algorithms consistently underestimated the rapid intensification of storms and entirely missed the extreme deviations in extratropical ocean heat near the 40th parallel. They failed because the models were fundamentally programmed to assume the ocean acts as a slow, stable heat sink. They were mathematically biased toward returning to average. But in 2026, there is no average to return to. The atmosphere has crossed a structural threshold. When the Pacific engine detonates its latent heat into the stratosphere, the models desperately try to force the simulated jet stream back into its historical 20th century boundaries. The algorithms aggressively attempt to dampen the anomaly. But reality refuses to dampen Forecasters are forced into the terrifying position of watching real-time satellite telemetry aggressively diverge from the supercomputer projections within just 48 hours of a forecast. Stay with me for a moment. This is the definition of the wildcard season. The institutions we rely on to issue the evacuation orders, route the global shipping lanes, and protect the agricultural supply chains are operating in the dark. They are trying to predict the behavior of a climate state that has never previously existed on Earth. And as the predictive models publicly collapse under the weight of the data, the scientific community is forced to make a deeply unsettling admission. The blueprints we have used to understand El Niño for half a century must be completely thrown away. Non-stationarity. It is a dry academic term. But in the halls of the world's leading meteorological institutions, in the summer of 2026, it has become a word of profound dread. In statistics, non-stationarity means that the fundamental rules generating a set of data have permanently changed. The past is no longer prologue. The game has a new board. Let's be precise about what this means for 2026. For nearly 30 years, the climatology community has treated the super El Niños of 1982 and 1997 as the holy grails of forecasting. They were the absolute blueprints for extreme weather. When the Pacific Ocean began to warm, forecasters would simply pull the 1997 maps out of the archive, overlay them on the current year, and issue their warnings with a high degree of confidence. In 2026, the scientific community is being forced to publicly abandon those blueprints. They are recognizing that using the 1997 analog is not just inaccurate, it is actively dangerous. To understand why, we have to examine a critical flaw in predictive mathematics known as the performance paradox. Think of it like this. If you train a highly advanced artificial intelligence to play chess, and you feed it every championship match from the 20th century, it will become an unbeatable master. But if you suddenly sit that AI down at a board where the knights are allowed to move diagonally, the machine's historical mastery becomes its greatest vulnerability. It will make brilliant, highly calculated moves that are entirely wrong for the new reality of the board. The supercomputers predicting the 2006 weather are trapped in this exact paradox. They possess excellent historical skill. They understand exactly how the atmosphere behaved during the 1997 Super El Niño, but they are completely blind to the nights moving diagonally. They are blind to the North Atlantic running a Category 5 marine heatwave. They are blind to the fact that the entire planetary baseline is 1.5 degrees hotter, meaning the atmosphere is physically holding 10% more water vapor than it did during the Clinton administration. Here is why this matters. When a forecaster looks at a model projecting the path of an atmospheric river over California, or the development of a hurricane in the Caribbean cauldron, they have to trust the math. But by mid-2026, the scientists are actively watching the math fail. They are watching models drastically underestimate the explosive rapid intensification of storms because the algorithms are mathematically anchored to a 20th century ocean that was physically colder and less volatile. The models are biased toward returning to an average that no longer exists. Let us maintain our intellectual rigor here. The forecasting institutions are not incompetent. The researchers at the National Hurricane Center and the Climate Prediction Center are the finest atmospheric physicists on the planet. But they are operating instruments that were calibrated for a different Earth. Stay with me for a moment. This is a monumental shift in how we understand risk. We build our dams, our levees, our coastal communities, and our regional insurance markets based entirely on the assumption that the worst-case scenario of the future will look roughly like the worst-case scenario of the past. But 1997 is gone. 1982 is gone. We are officially flying blind. The agencies are releasing their outlooks with unprecedented caveats, widening their cones of uncertainty, and explicitly warning the public that the historical analogs have been discarded. The Pacific thermal engine is still running, the global atmospheric architecture is still locked into its most violent configuration, and we are tracking the fallout with predictive models that are actively breaking down in real time. And even when this Super El Niño eventually peaks and begins to decay, the danger is not over. The ocean is not done with us. 500 zettajoules. That is the mathematical sum of the excess thermal energy absorbed by the world's oceans since the mid-20th century. But the sheer, unfathomable size of that number is not the part that has forecasters alarmed. It is the realization of what that energy fundamentally represents. It is not just a temperature reading, it is a debt. And by the end of 2006, the atmosphere is going to begin aggressively collecting on it. Let's be precise about what this means. There is a deeply ingrained public misconception that an El Niño event is a localized, temporary spike in the weather. The assumption is that once the trade winds return, the oceanic Kelvin wave dissipates, and the Pacific Sea surface temperatures cool back down to normal, the crisis is over. The Earth resets. But the Earth does not reset. The 22.6 climate system does not have a reset button. To understand the concept of thermal debt, we have to look at the mechanical relationship between the ocean and the atmosphere. Over the last 50 years, human-emitted greenhouse gases have trapped immense amounts of heat in the climate system. But the air does not hold most of it. The global oceans have acted as a planetary-scale sponge, silently absorbing over 90% of that excess thermal energy. Oceanographers measure this trapped energy in zettajoules. A single zettajoule is roughly equivalent to 25 billion atomic bombs. In the years immediately preceding 2026, the oceans were absorbing 15 to 20 zettajoules of heat annually. This energy does not simply vanish. It is physically shoved down into the water column, stowed away in the dark, crushing depths between the surface and 2,000 meters down. Think of it like this. The ocean has spent decades acting as a high-interest credit card, artificially subsidizing the atmosphere, protecting us from the true, explosive cost of our planetary warming. But a super El Niño changes the terms of the loan. When the Pacific thermal engine detonated in 2000 and 2006, it violently churned that stored heat to the surface and exhausted it into the sky. It fundamentally altered the jet streams. It engineered the whiplash in California. It built the Caribbean cauldron. But even when this specific El Niño eventually decays, even when the equatorial Pacific transitions into a cooling La Niña phase, the deep ocean will not be empty. Here is why this matters. Because of the 1.5-degree elevated baseline, the climate system physically cannot exhaust the sheer volume of heat released during the 2026 El Niño before the baseline is pushed upward again. The Pacific will cool on the surface, but the unseen subsurface water will retain a massive, highly pressurized reservoir of latent heat. Climatologists call this ocean heat memory. The water remembers the anomaly. The thermal debt remains locked in the global system. This means that for the entirety of the next decade, the resting heart rate of the planet will be permanently elevated. Even during neutral weather years, the oceans will continue to radiate an unnatural elevated level of moisture into the lower troposphere. The sponge of the sky will remain hypersaturated. The baseline for normal weather has been eradicated. Stay with me for a moment. This is the sobering, unyielding reality of the unseen energy debt. The 2026 Super El Niño is not an isolated event that we simply have to survive. It is a thermodynamic threshold. It has unlocked a deep-sea thermal reserve that guarantees heightened atmospheric violence, intensified rapid hurricane intensification, and more frequent flash droughts for a generation. The ocean has shielded us for half a century. The shield is now fully saturated. And as we look at the physical defenses we have built to protect our cities, our agriculture, and our coastlines, we are about to realize that 20th century concrete cannot hold back 21st century physics. 61 years. That is the average age of the 92,000 dams currently holding back the rivers and reservoirs of the United States. But the physical degradation of the concrete is not the part that has civil engineers terrified. It is the mathematics that the concrete was poured to manage. We are defending our cities with an infrastructure network that is fundamentally, mathematically blind to the water of 2026. Let's be precise about what this means. Civil engineering relies on a concept called the design storm. When a dam, levee, or spillway is built, hydrologists look at decades of past precipitation data to calculate the absolute worst-case scenario, the so-called 100-year flood. They build the concrete to hold exactly that amount of water, plus a narrow margin of safety. But, as we established in Part 21, the historical data is obsolete. The 1.5-degree elevated baseline of the planet has increased atmospheric holding capacity by 10%. The Pacific thermal engine has re-engineered the jet stream to systematically mass-produce Category 5 atmospheric rivers. The design storm of the 20th century is the standard Tuesday rainstorm of the wildcard season. To understand the mechanical reality of this infrastructure deficit, we have to look past the dramatic image of water flowing over the top of a dam. The true structural vulnerability of the American water system lies in the thousands of miles of earthen levees defending the Mississippi River Basin and the California Central Valley. When the historic floodwaters of 22,000 finally reach these river systems, they do not just rise, they apply profound, sustained mechanical stress. Hydrologists call this hydraulic head pressure. Think of it like this: water is unimaginably heavy. When a river swells to 30 feet above its normal stage, millions of tons of water are pressing outward against the earthen walls of the levee. This sheer physical weight searches for any microscopic vulnerability in the earth. And it does not usually find it at the top, it finds it underneath. This introduces a terrifying failure mechanism known as underseepage or piping. As the floodwaters sit against the levee for weeks on end, the intense hydraulic pressure physically forces water down into the permeable soil beneath the levee's foundation. The water travels under the structure and bubbles up on the dry side of the wall. At first, it looks like a harmless puddle, but the water is not just moving, it is carrying microscopic grains of sand and silt with it. Slowly, methodically, the pressurized water begins to hollow out a subterranean tunnel, a pipe, directly beneath the millions of tons of earth holding back the river. It pushes, it burrows, it erodes. Once the pipe is fully formed, the structural integrity of the levee instantly drops to zero. The earth above the hollow tunnel collapses, and the entire levee violently blows out from the bottom up. There is no warning. There is no slow overtopping. There is simply a sudden, catastrophic detonation of water into the floodplains. Here is why this matters. In a standard El Niño year, a localized section of levee might face this kind of pressure for a few days before the water recedes. But the 2026 atmospheric configuration, the southern shifted jet stream and the locked-in Aleutian low guarantees that the floodwaters are not going to recede. The rivers are going to remain at major flood stage for months. The hydraulic head pressure is going to test thousands of miles of earthen levees with a duration and intensity they were never engineered to withstand. Stay with me for a moment. This is the definition of an infrastructure deficit. We are attempting to catch a 10 trillion gallon atmospheric fire hose in a bucket that was mathematically sized for a 20th century garden hose. And the bucket is already full. The dams will be forced to release maximum capacity simply to save themselves, artificially flooding the downstream rivers and accelerating the hydraulic pressure on the levees. The failure will not be localized. It will be systemic. And as the physical barriers of the modern world give way to the physics of the anomaly, society is forced to confront a reality that is far more damaging than the water itself. Rates of post-traumatic stress disorder among survivors of extreme climate disasters are now statistically mirroring the rates documented in combat veterans. Let's be precise about what this means. A weather event does not just destroy a physical zip code, it systematically dismantles the psychological architecture of the people living inside it. In the aftermath of the 2026 wildcard season, the most profound deficit in the United States is not measured in trillions of gallons of water or billions of dollars in agricultural losses. It is measured in cognitive collapse. To understand this psychological toll, we must examine a clinical term that has rapidly transitioned from an academic niche into a widespread planetary diagnosis: solastalgia. Coined by environmental philosophers, the word marries the Latin root for comfort, solacium, with the Greek root for pain, algos. It describes a highly specific, agonizing form of existential distress. It is the profound, debilitating homesickness you experience when you have not physically left your home, but your home has been fundamentally transformed into an unrecognizable, hostile environment. Think of it like this. Standard homesickness is the pain of being away from the familiar. Solastalgia is the trauma of watching the familiar be permanently erased while you are still standing in it. Here is why this matters for 2026. Historically, humanity recovers from natural disasters through a predictable psychological cycle. The hurricane hits, the community grieves, the insurance checks clear, and the houses are rebuilt exactly where they stood. The human brain is incredibly resilient when it believes the threat has passed and the equilibrium can be restored. The recovery is anchored by the belief that the disaster was a localized, anomalous fluke. But the 2006 Super El Niño, operating on a 1.5-degree elevated baseline, mathematically eradicates that belief. The residents of the American Gulf Coast are not recovering from a single hurricane. They are enduring a 3-month, uninterrupted barrage of nocturnal tornadoes. The farmers in the Midwest are not waiting out a bad season. They are watching their deep subsoil chemically bake into dust. The citizens of California are not just digging out of a flood. They are watching the fire-scarred mountains above them physically liquefy and absorb their neighborhoods. We must explicitly detach from the idea that the brain can simply adapt to this. The human nervous system did not evolve to process perpetual, compounding, multi-front environmental trauma. It requires a baseline of safety to regulate itself. When the baseline of safety is permanently removed, the nervous system gets stuck in a chronic, unyielding state of hyperarousal. Stay with me for a moment. This is the true insidious danger of the word unprecedented. For decades, meteorologists and politicians have used that word to describe the worst-case scenario. It was an alarm bell, but when a Category 5 atmospheric river, a winter without snow, and a Category 5 marine heatwave are all occurring simultaneously, unprecedented loses its meaning. It ceases to be an emergency. It becomes the baseline operating condition of the Earth. When unprecedented becomes the everyday reality, the psychological toll transitions from acute anxiety into widespread structural paralysis. Communities realize that the levee cannot simply be rebuilt taller because the physics of the water have fundamentally changed. They realize that the insurance markets are not just paused, they are mathematically dead. The illusion of mastery over nature, the central pillar of modern human psychology, is violently shattered. This is the hidden casualty of the 2026 climate giant. The Pacific thermal engine did not just rewrite the global jet stream, it forced society to confront the deeply terrifying, mathematically undeniable reality that we are no longer visitors in a temporary crisis. We have physically crossed the threshold. And as we look forward to the years following this specific Super El Niño, the scientific community is preparing to announce that the transition phase is officially over. The old world is not coming back. 1.5 degrees Celsius. For 3 decades, that number was the mathematical North Star of global climate policy. It was the absolute ceiling negotiated in the Paris Agreement. It was universally framed by politicians and scientists as the cliff edge we needed to avoid at all costs. But in the aftermath of 2006, the scientific community is forced to make a deeply sobering structural admission. We did not avoid the cliff. We drove directly over it. Let's be precise about what this means. The 1.5 degree threshold is no longer a future warning. It is the current, verifiable, physical baseline of the planetary atmosphere. The catastrophic weather of the 2026 Super El Niño was not a freak occurrence. It was the mechanical byproduct of an Earth system actively operating in the red. To understand the era we have entered, we must entirely abandon the phrase, the new normal. It suggests that the climate has shifted from one stable state to another, that the storms are worse now, but they will eventually level off and behave predictably within a new set of boundaries. There are no new boundaries. The planetary baseline is not stabilizing at 1.5 degrees. It is actively, relentlessly climbing. As long as the global economy continues to inject millions of tons of greenhouse gases into the atmosphere every single day, the physical laws of thermodynamics dictate that the atmospheric holding capacity will continue to swell and the ocean heat content will continue to aggressively compound. Here is why this matters. The 2026 Super El Niño was the most destructive climate event in modern history, but it was operating on a 1.5 degree baseline. When the next major Pacific thermal engine turns on, perhaps in 2035, perhaps in 2040, it will not be colliding with the atmosphere of 2026. It will be colliding with an atmosphere that is 1.8 or 2.0 degrees hotter. The mathematical ceiling for violent convection, hydro whiplash, and marine heat waves will be physically raised again. Think of it like this. We are no longer playing a game with fixed rules. We are playing on a board where the underlying physics are being rewritten in real time every single year. This is the definition of the wildcard era. We have entered a geopolitical and meteorological reality where the past is mathematically obsolete. The dams we built cannot hold the water. The insurance markets we designed cannot pool the risk. The supercomputers we rely on to issue the warnings are systematically blind to the scale of the thermal energy trapped in the oceans. Let that sink in for a second. We are no longer waiting for climate change to arrive. We are not anticipating the collapse. We are currently living inside the first unmapped, highly volatile chapter of it. We must maintain our intellectual honesty here. Humanity is not facing extinction. The species will survive the wildcard era, but the infrastructure of the 20th century, the predictable planting seasons, the 30-year coastal mortgages, the static flood zones, and the illusion of absolute mastery over the natural world will not. The Pacific Ocean woke up in 2026 and delivered a planetary-scale shockwave. It engineered a year of impossible facts and broken models. But the most terrifying truth of the 2026 wildcard season is not what it destroyed. It is the realization that 2026 was not the climax. It was merely the prologue.